So on Desmos, what we see here is I have a quadratic equation. I have a parabola in red on the screen here, okay? And the equation for this doesn't really matter. It's 1x squared plus 5x plus 8, okay? Now, I want to show you this. I want to show you if I make a 0, what does that turn that graph into? What does that look like to you now? It looks like a straight line. So if a is 0, that means that this ax squared right here is all 0. So we have y equals 5x plus 8. That is a straight line. Okay. Now, this is what we are aware of. You are aware of an inequality that looks like this one. So if y was less than this line of 5x plus 8, we would shade one side of the line. And 0, 0, if I put 0 in here and 0 in for x, 0 is less than 8. That is true, so it's part of the solution set. This is what we know already, okay? Now, if I had the parabola back, watch this, see how that parabola bends up there, and if I were to light up this inequality, we should have a shaded region as well. That would be a solution set, because there's two variables involved. So let me go back to the line. Okay, all right, where is it? Right here. I'm gonna light this. Now watch, if I actually make this into a quadratic, look what happens. The line bends up, and so does the solution set react. So the only difference between 9.2 and 9.1 and 9.3 inequalities in two variables is that the boundary line is a line in 9.1. Here, the boundary line is actually a boundary curve, and it's quadratic. It's a parabola. So everything is exact same. You would graph the parabola instead of graphing the line, determine whether it is solid or dashed, and then use test points either on the inside of the parabola or the outside of the parabola and shade the appropriate region. Okay? Isn't that pretty easy? All right. So again, if I change this sign right here, if I change this sign instead of less than or equal to greater, if I change it to greater than or equal to, what do you think should change on my graph there?
Inside should be shaded.
It should be the inside that's shaded, and check that out. Look at that. The line, again, if it was a line and I had greater than, well then this side should be shaded. So guess what? Okay? So everything is exactly the same. All you do is graph a parabola now instead of a line boundary, and then pick test points in and out. Okay? And that's in two variables, so we need to shade. Okay, so consider this graph right here, similar to the one I just showed you. I have two variables, y and x. So I know that I'm going to have to shade something. And you can write this one down. Okay, this example here. So it's two variables, x and y. And so I'm going to have to shade part of the coordinate plane. The boundary line is not a line anymore. It's a parabola. So we have a boundary parabola. Okay. I do have to consider whether this boundary parabola, if I could speak, is it solid or dashed? So solid or dashed boundary. And of course, in this case, there's no or equal to, so I know that it's dashed, right? And that's what happens. That's what's happening here. And then finally, I would just pick a test point, and 0, 0, remember, is really the easiest test point to pick. So just use a test point, and then shade the appropriate region. So 0, 0. Well, 0, is that less than 0 minus 3? So is 0 less than negative 3? The answer is no. So guess what? 0, 0 is not part of the shaded region. You would shade everything on the other side of the parabola, like this. Okay? Super easy, super straightforward. All right? So inequalities with two variables that are quadratic expressions you do the exact same thing as if it were linear, but your boundary line is going to be a parabola. It could open up or down, and you either going to shade inside, because there's no real inside, right? But you can shade inside or outside of the parabola, whichever is appropriate.